Unit 4, Part 4. Let's move on to Section 2. The big lesson of Section 2 is one I've already spoken of at length in previous lectures on previous units. It is that sentences built with non-truth functional sentential operators are from now on treated as simple sentences. Okay, so remember in Unit 2 you're already introduced into you introduced the idea of sentential operator, right? Because that goes with the idea of simple and compound sentence. What is a compound sentence? It's a sentence built with a sentential operator, right? And the general notion of sentential operator included, and the general notion of a compound sentence in English allowed us to recognize, and for the first quiz you're asked to recognize a sentence like, Steve believes that Dan is Australian, as a compound sentence, right? Where Steve believes that blank is the sentential operator, simple component sentence, Dan is Australian, right? You can replace that with 2 + 2 = 4. Steve believes that 2 + 2 = 4. So yes, it's compound. Yes, it has a sentential operator giving it structure. But the big lesson of Unit 3, of course, was giving as our reason why the 5 sentential operators we choose to give symbols to are the ones we choose to give symbols to. Why? Because those sentential operators are truth functional, right? The truth value of the sentence built through all those operators is determined entirely by merely the truth value of the component sentences that go into it. And as explained in the lectures for Unit 3, that's the truth functionality of those operators is what makes a truth table for those operators possible, right? And it's because we limit ourselves to truth functional sentential operators that we have a truth functional system of logic, and we can do things like test an argument form for its logical validity. It's how we're able to show that a logical form, a valid logical form, cannot possibly have a counterexample, right? It's only because of the truth functionality of our operators are we able to exhaustively list everything that goes into determining the truth value of all the sentences in the argument form, right? Through the base columns. Sorry, this is looking ahead, but this will become clearer when you see it in Unit 5. But through the base, because our system of logic is truth functional, because we only operate with truth functional sentential operators, it's only because of that we can show that an argument form is valid by exhaustively listing in the base columns for a truth table the lists of TT, TT, FFFF, TT, FF, TT, FF, true, false. Exhaustively listing there everything that goes into determining the truth value of each of the formulas, and then with a complete truth table we can look at it and say, if there is no counterexample, no substitution instance, no row in the truth table where all the premises come out true and the conclusion comes out false, if there's none of them, there is no counterexample at all. The argument form is valid. Anyway, it'll go over your heads, I imagine, but wait for Unit 5. We'll get into it more. Anyway, where were we? Okay, so yes, the big lesson of Section 2, Unit 4, is that now that you've learned to recognize, got past the first quiz, and you have proven, hopefully, that you are familiar with the general notion of a sentential operator, the general notion of a compound sentence. Now, because we want our system of logic to be truth functional, we treat all non-truth functional, we treat all sentences which are officially compound, right? Like Steve believes that Dan is Australian. All sentences which are compound, where the sentential operator is a non-truth functional one, we treat all of them as simple sentences, right? So it's important to so when you're asked to the result is, when you're asked to translate a sentence like, Steve believes that Dan is Australian, when you're asked to symbolize that in our system from now on, Steve believes that Dan is Australian, no structure, no form. It's treated as a simple sentence. That means it just gets a capital letter. Go ahead. Translate Steve believes that Dan is Australian for me. It's just, okay, S. Pick a capital letter. Any capital letter you want. Well, the only correct answer, the correct answer is just one capital letter, right? No dots, no hooks, no structure, right? Because it's not a truth functional sentential operator, right? So the crucial passage here I'll read, second passage of section 2, page 54. What do we do then with operators such as because or possibly? So because is importantly a non-truth functional sentential operator, right? You can prove that, right? I gave you a couple of proofs for non-truth functional sentential operators, proving, right, demonstrating the non-truth functional, what the first question in your exam will be. Demonstrating an operator non-truth functional. She went through it with because. You should do it as an exercise. Okay, so what do we do with operators such as because or possibly? We may distinguish between truth functional and non-truth functional compounds. The former have a truth functional major operator and the latter have a non-truth functional major operator. The question is how to symbolize non-truth functional compounds. Sentences that have a major operator such as because or after. Right? Question is how to symbolize non-truth functional compounds. And we're going to say, well, we're going to treat them as if they're not compounds. We're going to treat them as simple. Since we cannot represent their structure by means of truth functional operators, and these truth functional operators are all we have in classical logic, we simply cannot represent their structure at all. So we must represent them as non-compound, simple sentences. Thus we will symbolize them by means of a single capital letter. Like so. S for Steve believes that Dan is Australian, right? Notice what you do get here. You can have sentences where the major operator is a non-truth functional one, you can have sentences where the major operator is a truth functional one, right? And that structure will get symbolized, will get expressed symbolically in our formulas. But maybe the components are compound, but where the sentential operator making it compound is a non-truth functional one. So the example she gives on page 55, think of this sentence: John went to the party because Mary was going to be there, comma, and Mary went to the party because Fred was going to be there. Okay? So, right, the and, I should say, whenever you see punctuation, the punctuation in an English sentence, especially a comma, sometimes semicolon, usually tip you off as to what the major operator is. A big part in symbolizing, we'll see, is correctly identifying the major operator. It's something you can go wrong on, right? You get, is it this if over here, or is it this and over here? Sometimes it's ambiguous, but usually you won't have ambiguous questions in exams or tests. But that sentence, right? So the comma and then and, that of course is our and, so that will get symbolized, so that's going to get a conjunction. But the components on either side, right, are compound but with non-truth functional sentential operators. So what goes to the left is the sentence, John went to the party because Mary was going to be there, right? Officially, John went to the party, Mary was going to be there. Those are the simple sentences, and blank because blank gives you the structure, so it's compound in the old way of thinking. But because it's the sentential operator is because, a non-truth functional one, we just ignore it. So the symbolization of this is just going to be J equals, right? J equals John went to the party because Mary was going to be there, and M, where M equals Mary went to the party because Fred was going to be there, right? So we treat, again, the whole lesson is we treat compound sentences built from non-truth functional sentential operators as simple sentences from now on.